Hello and welcome everyone. This is going to be a video explanation of my ESP32-S3 composite video library. So we're going to start off with a brief explanation as to what this is and what that means, and then we're going to pivot into a more in-depth technical explanation of some of the features of this library. So to start us off, this is a library written for the ESP32-S3, fairly common, very well supported and well known series of microcontrollers. And the purpose of this library is to generate composite video, better known as the red, white, and yellow plugs on the back of old TVs and game consoles. And it was even the video standard used to get a video out of the old iPods and iPhones up through the iPhone 4 to connect them to external displays. Now, I picked composite video because it's a very well supported standard. It goes back to the 50s. Connectors for it still appear on modern TVs today. So if you need to connect your microcontroller to a TV, you can very well assume that if you find a TV, it will support composite video in one way or another. So the library as it currently stands supports grayscale, 170 shades of gray, with 0 being the darkest, black, and 170 being the brightest, white. And with this 170 shades of gray, it allows it to render grayscale images. So here is a screenshot from a YouTube video, which I have converted to grayscale for demo purposes. And it also allows rendering of black and white images, meaning an image where the pixel is all black or all white. This allows, as opposed to the previous image, which requires 8 bits per pixel to specify the level of grayscale, this one can get away with 1 bit per pixel, which makes the image about 8 times smaller. And a currently experimental feature, which I'm working on, is the addition of color, although that is still very much in the works, an experimental feature. Now, moving on to a more in-depth technical explanation, a lot of the functions of this library, which allow accessing the stuff it can do, fairly self-explanatory. 1-bit dot allows you to specify an x and y coordinate on the screen, and whether or not you want that pixel to be white or black. 1-bit image is very similar, except instead of specifying 1 pixel, you specify the width and height of an image you'd like to draw, and the x and y position where it starts, and it will start at the top left corner and go along until it reaches the end, at which point it will jump back to the beginning and continue along another line, and then do that until it has reached the bottom of the image. You pass image data to this through an array, which is basically just a programming way of saying list. For example, this array right here is just a list of values, and you pass that to this, and it will just go through one by one and plot each pixel on that so that you don't have to do it manually. 1-bit change mask is very similar, except instead of specifying directly which the values of each pixel being either on or off, this one specifies if a pixel is changed. So if it's a 0, it doesn't change the current pixel, and if it is a 1, it does change the current pixel. This speeds up updating an image which has only changed slightly, so the way that a lot of video works, so there's a little bit of movement, but most of the stuff on screen stays the same. This helps speed that up. Mono dot is the same as 1-bit dot, except you can specify the actual value of the pixel. Anywhere from 0 to 255. This function will automatically compress it to 0 to 170, but 0 to 170 is a very weird number. 0 to 255, 8-bit grayscale is very common, so I had it automatically handle that. Mono image is basically the same as 1-bit image, except instead of 1 bit per pixel, it processes with allowing you to specify the values of each pixel, so it's a little bit slower, but you get more detail. And then color dot is the experimental functions that I'm using to add color. I also wrote for this library a wrapper for Adafruit GFX, which is a very common library. There's a bunch of YouTube videos and explanations and online documentation of how to use Adafruit GFX, including a bunch of example code that you can basically just copy-paste into a project using this library, such as I've done here, where I can specify the cursor, I can print text on screen. Once color is implemented, you'll be able to change the color of all the stuff you do with it. You can draw basic shapes. This allows you to use a lot of the example code. And then now I'm going to answer a question which I get asked very commonly, which is if you can support grayscale as this library does, why would you even bother grayscale as this library does? Why would you even bother with 1-bit color like this when you can have grayscale? And the answer with that is severely reduced file sizes. So a 720 by 480 image, which is the closest resolution to the resolution that this library runs at, in 8 bits is about 345 kilobytes, so right about 400, which is 70% of the RAM that the ESP32 has at all. Not counting, and that doesn't take into account the amount of RAM that you would need for storing your actual program that you're running and variables that it would use. So basically, even using one image with this becomes incredibly difficult. Whereas if you reduce it to 1-bit monochrome grayscale, it reduces it to just over 43 kilobytes, which is a much more manageable number. You can fit 2 images then within 100 kilobytes and still have a bunch of data left over. And for the vast majority of situations, especially on a microcontroller, the reduced color depth doesn't matter. This image is very flat, consists of a lot of lines and simple shapes. You don't really lose all that much not having grayscale. Same for a lot of white text on black backgrounds. Grayscale color depth doesn't really matter in that application. So it's nice to have the option to have the severely reduced file size, even if you do wind up dealing with a lot of images. Because then you can just have the images which absolutely have to be grayscale take up a lot of space, and any that don't, you can render with the lower amount. So you don't have to deal with a bunch of big images, you can just deal with a couple, and then the rest of them are relatively smaller by comparison. So that wraps up my general explanation. If you have any questions, comments, or concerns, please leave them in the comments, and I will be happy to answer them. Thank you very much for watching.